For this question, it is on quadratic function, but however, the second part of the quadratic function has a bit of relation to your gradient concept, which is your dy dx. Okay, so we start off with the curve having a quadratic equation. So if you look at the equation, the first thing you should realize that it's a quadratic function. Then take note of the description. There are 2 points on the curve. If you want some visualization, you can have a bit of idea about the curve if you want to. By looking at the shape. So by now, you should be able to estimate the idea of the shape. So the shape will be a set face graph, and it will look something like this. Okay, so if you have an idea about the sketch, it will help you with the visualization. Okay, so there are 2 points on the curve. So there's a point A and then there's a point B. Okay, so randomly you can just choose. So maybe this one is point A, where the x coordinate is k, and then here the x coordinate is 2k. Okay, so I'm just randomly putting a coordinate there. Okay, so you are given that k is between 0 to 7. Okay, so look carefully when they phrase part A. So there will be some students who cannot process part A. Okay, so find the range of values of k for which the y coordinate of B. So we got 2 things in concern. The 2 things in concern will be the y coordinate of B and also the y coordinate of A. So this will be the 2 things that you will need to be able to come up with it based on the information. So if you read carefully the information, we know that this is the x coordinate. So we do have the x coordinate of A. So with the x coordinate, if you just put it back into the equation of the curve, you will be able to get the y coordinate. So we just do a simple substitution. So when x is equal to 2, you put it into the equation. So this whole thing will be the y coordinate. That will be the y coordinate of A. And when x is 2k, again, you put it inside the equation, but do be careful about the squaring. So if anyone forget the bracket and then you go and square it, you will make a mistake. So those who forget the bracket, you will end up with a 2k squared. Those with the bracket, you will end up with 4k squared. So that's the effect of missing out the bracket. So your idea is to extract the y coordinate of the 2 coordinates. So these are my 2 concerns. The y coordinate of A and B. So we use the information that's provided to us that the y coordinate of B is greater than the y coordinate of A. So this is the information they provide us. You just execute it. Okay, so while you put in the respective y coordinate, you realize that you will get a quadratic function in K. So you reshuffle them. Flip this over. Okay, personally, I do not like to see quadratic function when it is negative. So like I don't like to see this as a negative. So my usual habit is to divide by -1. So you do need to remember that if you divide by -1, the sign will be reversed. So this part, you are being tested on quadratic inequality. So you are being tested on quadratic inequalities. So where you got to do the shading. So this shading is meant for the values of K. So at this point of time, the quadratic function that you are facing is the quadratic function for the values of K. So don't mix it up with the quadratic function for X. It's not. Okay, so don't take it. This is for the values of K, whereas this is for the value of X and Y. So it's 2 different things. So do not take it as the other thing. So look at the axis. they are measuring different things. So the last part of this question is testing you on the quadratic inequality. So if after I reverse the sign, it will be less than. So I'll be shading the portion of the graph that is below the horizontal axis. So that's how I gotten my answer. That's how I gotten the range of K. Okay, the next one talks about the gradient at A. We are supposed to explain that the gradient is always greater than the gradient at B. So gradient should relate you to think about dy dx. So gradient should relate you to think about dy dx. So in this case, I do a very basic differentiation that will have given me the gradient function. So remember, dy dx is always a gradient function. So it's a gradient formula. So it is just a formula. If you insert different x coordinate, it will be a different value. So in order to find the gradient at A, I'm going to put in the x coordinate for A. So when I put in the x coordinate for A, I achieve the gradient of A to be this expression. So I'm going to find the gradient at B by putting in x equal to 2k. So at this point, I also get the separate gradient. Okay, so how am I supposed to explain that the gradient at A will be the gradient at greater than the gradient at B? So I'm going to try subtracting. I'm going to find out the difference between the two gradients. If the difference is positive, that means, right, A is bigger than B. So I will be using the gradient at A to subtract away the gradient at B. So if I do a subtraction and eventually I got a positive value, means that the gradient of A will be greater. Okay, so we'll just do a normal subtraction. Do remember your bracket. So it's a very simple operation. It's not very challenging. It's just linear subtraction. So eventually the difference between the two gradient is 2k. So I can safely say that 2k is greater than 0. Okay. If you want a more detailed explanation, you can say something like, since, don't forget, you are restricted by the value of k here. You are restricted by the value of k here. So 2k will be 0 to 14. So meaning the difference between the two gradients will always be positive. So you can explain a bit more detail in using the given information about k. So okay, once you deduce that the difference is always positive, you shift it over, it will be quite clear that the gradient at A is greater than the gradient at B. Okay, so this question is mainly on quadratic function. It tested you on the quadratic inequality, and it also relate a little bit on the gradient function.